In mathematics, a real-valued function or real function is a function whose values are real numbers. In other words, it is a function that assigns a real number to each member of its domain. Many important function spaces are defined to consist of real functions. In general, let X be an arbitrary set. Let denote the set of all functions from X to real numbers R. Because R is a field, is a vector space and a commutative algebra over rails. Vector addition, additive identity, scalar multiplication, pointwise multiplication. Also, since R is an ordered set, there is a partial order on is a partially ordered ring. Measurable. The sigma algebra of Borel sets is an important structure on real numbers. Measurable functions also form a vector space and an algebra as explained above. Moreover, a set of real-valued functions on X can actually define a sigma algebra on X generated by all preimages of all Borel sets. This is the way how sigma algebras arise in probability theory, where real-valued functions on the sample space omega are real-valued random variables. Continuous real numbers form a topological space and a complete metric space. Continuous real-valued functions are important in theories of topological spaces and of metric spaces. The extreme value theorem states that for any real continuous function on a compact space its global maximum and minimum exist. The concept of metric space itself is defined with a real-valued function of two variables, the metric, which is continuous. The space of continuous functions on a compact Hausdorff space has a particular importance. Convergent sequences also can be considered as real-valued continuous functions on a special topological space. Continuous functions also form a vector space and an algebra as explained above, and are a subclass of measurable functions because any topological space has the sigma algebra generated by open sets. Smooth real numbers are used as the codomain to define smooth functions. A domain of a real smooth function can be the real coordinate space, a topological vector space, an open subset of them, or a smooth manifold. Spaces of smooth functions also are vector spaces and algebras as explained above, and are a subclass of continuous functions. Appearances in measure theory. A measure on a set is a non-negative real-valued functional on a sigma algebra of subsets. LP spaces on sets with a measure are defined from aforementioned real-valued measurable functions, although they are actually quotient spaces. More precisely, whereas a function satisfying an appropriate summability condition defines an element of LP space. In the opposite direction for any FLP and XX which is not an atom, the value f is undefined. Though real-valued LP spaces still have some of the structure explicated above. Each of LP spaces is a vector space and have a partial order, and there exists a pointwise multiplication of functions, which changes P. Namely, for example, pointwise product of two L2 functions belongs to L1. Other appearances. Other contexts where real-valued functions and their special properties are used include monotonic functions, convex functions, harmonic and subharmonic functions, analytic functions, algebraic functions, and polynomials.